on volume. All right, so this is for the notes. So hopefully you're listening to this one first, but if not, either way, make sure you check this one out because this is important for the notes. All right, so first of all, we got this thing up here. It gives us a definition. We got density is the amount of matter that an object has in a given unit of volume. All right, so it gives us this formula. Density equals mass over volume. One way you can remember this, if you forget how to set up the formula, this is what I've heard, this is how I was taught, is density equals, it says, we love density. Actually, no, we don't. So we draw a line through the heart. Notice there's an M on top. That looks like an M. And then we've got a V on the bottom. So if you forget the formula, draw a little heart and then cross it out. And you got the M's on top and then the V's on the bottom. So that's one way to remember it, mass over volume. And kind of similar to like the population density ones where it was the population over the area. It's the same type of thing. You're always going to come back to the formula anytime we're dealing with density and volume, mass over volume. Every single time. Always start from that formula. All right. So we got the first example here. It's got a diagram shows the dimensions of a standard gold bar at Fort Knox. Gold has a density of 19.3 grams per cubic centimeter. Okay. That's something we need to be aware of. Per cubic centimeter. So we're in centimeters here. Our dimensions are in inches. So we're going to need to convert these into centimeters. All these guys need to get converted to centimeters. Something to be aware of. And then it says, find the mass of a standard gold bar to the nearest gram. All right. So again, we go back to that formula. Density equals mass over volume. And it wants us to find the mass, right? We're looking for the mass. So what that means is we're going to be able to plug something in for the density, and we're going to be able to plug something in for the volume, right? Well, density is our easy one because it just straight up gives us the density, right? Density is 19.3 grams per cubic centimeter. 19.3, that's your density. And then it equals mass, which is what we're trying to find, over volume. So that means we've got to be able to plug something in for volume. So first of all, before we do that, let's go ahead, convert the inches into centimeters. Whenever you're dealing with volume, these problems, and we've got to convert from one unit of measurement to the other unit, go ahead, do the conversion first, and then find the volume. All right? It's a bit of a complicated explanation why. I'll explain that in detail if you want when I come back. It's easier to do in person. But for now, just know, always do the conversion first and then plug into the formula to find that volume. All right, so let's do the conversion. 1 inch is 2.54 centimeters, right? So centimeters are smaller than an inch, so we're going to have more of them, right? For every inch, we've got about 2.5 centimeters. So all of these measurements are going to be getting multiplied by 2.54. All right, so you can get out calculator if you want. Follow along with me as I do this on my phone calculator. So 7, we're going to multiply that guy by 2.54, right? Because we're converting all these to centimeters, right? So that's going to be 17.78 centimeters. And then 3.625 times 2.54. We're going to convert that one as well. That gives you 9.2075. And notice these are all in centimeters now. And then that last one, 1.75. We're also going to multiply that guy by 2.54. So over here we have 4.445. All right, so now all of our units are in centimeters. And if you remember how to find the volume of like a rectangular prism, right, which is like this bar that we've got here, this gold bar, it's just the length times the width times the height. So volume equals the length times the width. Notice I'm using the centimeter measurements, right, because we want the volume in centimeters, times the height. And notice all these measurements, these are all in centimeters now. Those are in centimeters. All right, so go ahead, do that multiplication on your calculator, or just give me a second while I do it on my phone. Times 4.445. Okay, and that comes out to 727.688, and then some more decimals. We don't need to worry about that. All right, and remember, that was your volume. That's our volume in cubic centimeters. All right, so we're going to go ahead and put that in for V. So I'm going to raise V and put the volume there because that's what the volume is. That's what we just found. All right, let's put that in there. So we got 727.688. All right, so let's find the bar to the nearest gram. All right, oh, sorry, find the mass of the bar to the nearest gram. So we're going to multiply by 727 on both sides, right? Because we want to cancel this out. So we're going to go times 727.688, cancel over here, times 727.688, and that's going to give us a final answer of, let's see, M equals 14,044 grams. And notice it says round it to the nearest gram, so the nearest whole number. Like you'll get some sort of decimal after that. We're rounding it to the nearest whole number. So there we go. 14,000 grams right there. All right. Well, let's keep going. Next example. So we got the wood from a live oak has a certain density. Find the mass if it has a length of 10 and a radius of 2. And notice, these are in feet, 10 feet and 2 feet. However, our density is in cubic centimeters. So we need to convert those feet into centimeters so we can be using the same measurements, all right? So notice whenever they give you these conversions, that's a hint that they're going to want you to convert it into something else. All right. So first of all, let's draw this log that they're giving us. So it says we've got a length. No, that was disappointing. Let's try that again. We've got a length of 10 feet. So the length of 10 feet and a radius of 2 feet. All right, so when we're talking about the radius, right, we're talking about the radius of like those bottom circle and that top circle. That's the radius we're looking for whenever they say radius. Okay, but we want to convert those, the feet into centimeters, okay? So first we can convert feet into inches by multiplying by 12. All right, so 10 feet multiplied by 12 would be 120 inches. 2 feet multiplied by 12 would be 24 inches. And then we can convert inches into centimeters, right? Just like we did last time, multiplying by 2.54. So 120 times 2.54 is 304.8 centimeters. That's your new height. And then for that radius distance, it's going to be 24, right? Because we have 24 inches was the radius times 2.54. So that gives us a radius of 60.96 centimeters. All right. I'll just circle these so we remember what they are. That was our height, and that was the radius. All right. Don't forget, anytime we got density with volume, we want to keep going back to that formula. All right. Density equals mass over volume. All right. So our density is given. It's 0.977. Equals the mass. And the mass is, again, what we're looking for, right? It says find the mass. So that means we'll be able to plug something in for the volume. And sure enough, once again, we can, right? Because we have a height, we have a radius, and that's all we need to get the volume of a cylinder. So if you remember the formula for volume of a cylinder, it is pi times the radius squared times the height. So let's substitute what we know about the radius and the height. So the radius is 60.96. Don't forget to square it. Times the height, 304.8. And this will go straight into your calculator. Make sure when you square it that the only thing you're squaring is that 60.96, right? Because we're only squaring the radius. And then whatever you get, so multiply that, do that, square it, multiply it by pi, multiply it by 304.8. All right, I'm going to do that as well on my phone. And that should give an answer of, that's a pretty large answer, So for our volume, that gives us 3,558,399. All right, I wish I could scroll down on here. Unfortunately, I can't. Okay. Oops. All right. Okay, I'm gonna just write it up here. So our volume was 3,558,399.89. Okay. And remember, that's our volume. So density equals mass over volume. So that number goes right here. Mass over 3,558,399.89. And again, that number came from using this formula to get the volume of the cylinder, right? Mass over volume. Volume is that cylinder, that log from the problem. Okay. Last thing you're going to do is multiply that over to the other side, and you'll get the M all by itself. So you'll multiply 0.977 times that 3 million number. And that should give you one sec. I'm having calculator issues. Bear with me. Okay. All right, there we go. It gives us 3,476,556. That will be the mass. All right, so solving this problem right here, right, we multiply that 3 million number by 0.977. That will give you that 3,476,556 grams equals the mass, right? Well, notice that this is in grams still, right? Because that density was in grams per cubic centimeter, right? The density was in grams. So we have one last step to do. It wants it to the nearest kilogram. So if it wants it to the nearest kilogram, the last thing we got to do is divide it by 1,000. Because there's 1,000 grams makes up 1 kilogram. So you got to be really careful about the units here. That's by far the hardest part of these problems. All right, so lastly, let's divide this by 1,000, and that's going to give you, once you round it up to the nearest, once you round it to the nearest whole number, the nearest kilogram, it's going to give you 3,477 kilograms is the mass. And there it is. There's the mass of the slog. All right, one more. These are long. Okay, we got a harvester who's interested in the volume of a trunk because most of the wood is there. Okay, it's got a height of 50 meters. Let's go ahead and draw this. Height is 50 meters, and the base diameter is about 0.8 meters. If the density is 450, find the mass. So again, we're finding the mass. So density, mass over volume. Okay, so our density is right here, 450 kilograms per cubic meter. And it says find the mass. So that means we're looking for the mass. So we need something to plug in for V. We're going to look for something to plug in right here for that V. All right, well, again, mass, exact same thing. Volume equals pi times the radius squared times the height. Because again, we're dealing with a cylinder, tree trunk shaped like a cylinder. The good thing, though, is notice that everything that we've got, all of our weight is in kilograms, and all of our length measurements are in meters. That's beautiful because it means we don't have to do any conversions because all our weights are the same thing. They're all in kilograms. All of our units of length, they're all meters. So it's going to make this problem a lot easier, a lot quicker to do. Okay, so pi r squared height. So the radius is that 0.8. So we got pi times 0.8 squared. And then the height is that 50. Again, that comes from here. The height is 50. And oh my goodness, the diameter is 0.8. Okay, so if you're watching this and you're wondering, what is he talking about? Yes, I didn't read that. The diameter is 0.8. That's super important. Okay, so if the diameter is 0.8, that's all the way across. I just caught a mistake, and I'm sorry. I'm 15 minutes in. I'm not going to restart the video because it's late at night. So if the diameter is 0.8, the radius, that's half of the diameter, right? Diameter is all the way. Radius is half of it. This is why you read the questions. Don't be like me. Okay. The radius is half of the diameter. So the radius, half of it is actually 0.4. So notice, if they give you the diameter, you're going to cut it in half every single time for these formulas, because these volume formulas are always going to want the radius. So don't forget to cut that diameter in half. All right, so right here, that 0.8 needs to be a 0.4. All right, so pi times the radius, which is 0.4, not 0.8, squared times 50, which is the height. All right, so take that to the calculator, punch that in, get your volume. And it should be about 25.13. So volume is about 25.13. What units are we in? We are in cubic meters. All right, so that's what we're going to plug in for volume down here. So 25. I don't know what just happened. My screen just glitched. We got 25.13 meters for our volume. So last thing, again, same thing as always, multiply that over to the other side. So 450 times 25.13, that's going to be your answer. That'll be the mass. So 450 times 25.13, that gives you a mass of 11,308.5 kilograms. Sorry, 11 million. 11,308.5 kilograms equals the mass. And again, all we did is we took this and we multiplied it by 450. And there's your answer. There's the mass. Okay, so you recap. Density equals mass over volume. Oftentimes in these problems, they're giving you the density. You have to use a volume formula to find the volume. And then you're going to multiply the volume over to the other side. The tricky part is when you're finding that volume, make sure you convert the units into whatever lengths and measurements that they actually want, right? Like if we're using centimeters, but the measurements they gave you are in inches, convert inches to centimeters, and so on. And they're always going to give those to you. You don't have to have all those unit conversions memorized. Just be aware that you're going to have to use them when it gives you the little unit conversions in there. All right. As always, let me know if you have any questions. Good luck.